You are welcome to today's lesson, and this is the first lesson in this new year. And I want to welcome you to say to you Happy New Year once again. Now, in the lesson today, we are looking at application of differential calculus, and we are still continuing with these tutorial questions 2020-2021, and we are now at question 27, which reads: find the rate at which the volume of a spherical balloon is increasing if the surface area is increasing at a rate of 5 centimeter squared per second, where the radius of the sphere is 4 centimeters. Now, how do you approach this question? First thing to notice is that we are dealing with two parameters here, the volume and the surface area. And this is a case of rate of change. So how do we approach this question? The very first thing is to get the formula for the volume of the spherical balloon. Now we come here, we write the formula, we say V, which represents the formula, the volume for the sphere as 4 upon 3 pi r cube. Okay, so the first step now is we have to differentiate this volume with respect to what? R. And in doing that, we have dV upon dr to equals, now we take this constant, which is 4 upon 3, and multiply it by pi, then multiply it by 3 will come to multiply all these things which is here, then r power was 3 minus 1. Now if you cancel this and this, you finally we have 4 times pi times what? R squared. That will give us 4 pi r squared. So which means that the r will become 4 pi r squared. Now take note that the radius is given to us as what? 4 centimeters. So let's plug that in here. We know that the radius is what? 4. And in plugging it here, we have 4 pi into bracket 4 then squared. Now 4 squared is what? 16. 16 times 4 is 64. So for the dV dr, we are going to have 64 pi. So this gives us dV dr to be 64 pi. Now the question, coming back to the question, you will see that the question says to us that we should find the rate at which the volume of the spherical balloon is increasing. So instead of stopping here, we need to get the rate at which the volume is increasing. And we can do that by saying dV dt. This is the rate at which the volume is increasing, and this is going to be equals to dV dr multiplied by dr dt. So you can see when the r and the r cancels, it leaves us with dV dt. So now what is our dV dr? Our dV dr is 64 pi. So which means that we are going to find an expression for dV dt to become 64 pi, then we have dr dt. Let's call this equation 1. So which means that if we know the value for dr dt, we are going to multiply that with this, and that will give us the rate at which the volume is increasing. Now, how do we get this expression for dr dt? This is now going to lead us to the second parameter in this question, which is the surface area, which is increasing at a rate of 5 centimeters squared per second. So we need to differentiate this surface area. Now, coming back to this place, we know that our surface area for sphere has the formula of 4 pi r squared. So we need to differentiate this with respect to what? To r. So this will give us ds dr to equals, now 2 times 4 pi r will give us 8 pi r, then we have 2 minus 1. So finally we have 8 pi r. Now we also know that r is what? Is 4 centimeters, and if we plug that in here, it's going to give us 8 pi times 4, and that will leave us with what? With 32 pi. So which means our ds dr will give us 32 pi. Now let us take this up here and continue. Now, if you go further, you will see that our ds dt would become ds dr multiplied by dr then dt. And if you check this particular expression very well, you will see that our ds dt is given to us in the question. And look at it, that is the surface area is increasing at 5 centimeter, or at the rate of 5 centimeter squared per second. So which means our ds dt here, we are going to replace it with 5, then equals to the value we got for ds dr. And if you check from what we did lastly here, our ds dr is 32 pi. So we bring it up here and we'll write our 32, then pi, then dr dt. So from this place, we can get the value for dr dt by bringing this 32 pi down. That is, it's going to be under 5. So therefore, our dr dt would become 5 all upon 32 pi. So let's call this equation 2. All right. So now we are going to put this value for dr dt. We are going to plug it into equation 1. So we can get our, we can say therefore our dv dt would become our 64 pi multiplied by the value for what dr dt, which is 5 upon 32. And if we solve this, you can see that 32 will cancel itself 1, and 32 pi, okay, the 32 pi will cancel 64 pi to give us 2. So our dv dt will become 2 multiplied by 5, and this is going to give us 10 centimeter cube then per second. So this is now going to be the answer for this question. I hope